Hello, everyone. We're the Waste Group, and our project is on global municipal solid waste production across countries with different income levels. I'm Grace.
I'm Alex.
I'm Schuler.
I'm Ming.
And then we'll be starting with our introduction, explaining our interest with this topic. So, waste is much more than just something we throw away. It has a significant impact on the environment and long-term sustainability. In this project, we'll be exploring how different factors influence waste management and what possible solutions exist to attempt solving this growing global challenge.
Before getting into our,
Municipal.
whoops. Oh,
Oh,
this
this
is
is not
over. I totally.
mine.
If you just continue, I'll fix this later.
Okay. Municipal solid waste is a major global environmental issue that reflects patterns of consumption, economic development, and population growth. Different countries generate varying amounts of and types of waste depending on factors such as income level, GDP, industry, and population size. Our research looks at how much waste is produced and what kinds of waste are most common in different countries around the world.
Before getting into our specific research questions, I want to explain why this topic matters. Municipal solid waste is not just about trash piling up. It connects directly to environmental public health, especially in places where waste is not collected, stored, or managed safely. Poor waste management can lead to pollution, exposure to harmful materials, and unequal health impacts on communities. This is also important because waste reflects economic activity. As countries develop and consumption patterns change, the amount and type of waste they produce also changes. By comparison, countries across income levels, we can better understand global differences and see how waste is connected to broader environmental and sustainability issues.
So, our overall research question is, how does global waste generation relate to economic and demographic factors? And to make this more focused, we developed three specific research questions, which are: what is the relationship between total GDP per capita, and total municipal production across countries with different income levels, low, medium, and high? For the second one is, how does municipal solid waste composition differ across countries with different income levels? And the third is there a relationship between annual CO2 emissions and total municipal production across countries with different income levels? And yeah.
Data sources and preparation. We got our data from water waste, worldbank.org. From this data set, our project had limitations due to lower income countries reporting less data. So the data was skewed with less countries, and they were mostly in the upper middle income range. We cleaned the data by singling out the year of 2022 because we found it was the year with the most data, and it's also a recent year, and we ended up with 56 countries. And the CO2 data was taken from Gapminder from the same year of 2022.
This slide shows part of the original code book from the World Bank's What a Waste dataset. This dataset was one of our main sources because it includes country level information about municipal solid waste, including waste composition, collection coverage, and other waste related measurements. The codebook was important because the raw data had a lot of different values, units, and source information. We had to identify which columns were useful for our research questions, especially total municipal solid waste generated, income level, population, GDP, and waste consumption categories like organic waste, plastic, paper, glass, and metal. Basically, this step helped us move from a huge raw data set into something cleaner and more focused for the analysis. This slide shows the original CO2 data from Gapminder. We used this source to add CO2 per capita values by country for 2022. Since our third research question looks at the relationship between annual CO2 emissions and the total municipal solid waste production, we needed a consistent CO2 variable that could be matched with the countries in our cleaned waste dataset. The main work here was matching country names and country codes because the two datasets Once we had CO2 per capita, we could combine it with the population to estimate annual CO2 emissions that allows us to compare waste production and emissions across countries and income groups.
The next three slides will be talking about our key data tables. So we combine and clean data from the World Bank's What a Waste project and Gapminder. And this data set basically covers countries across all income levels in 2022. And as you can see, each row represents one country, and we have columns like the country name, income group, economic indicators, waste generation, and waste composition. And then we'll move on to the next slide. And then these have more like middle and lower income countries. And then this data will help us to compare countries systematically across economic development levels. And then this slide will show the waste composition details, which we'll be digging deeper into in the next slides.
I'll be going into the descriptive statistics for this project. As you can see here, this is our entire descriptive statistics table. Obviously, for descriptive statistics, we're trying to measure the central tendency and dispersion or spread of your data set. Because there were so many variables, we did think it was equally important to show the mean, median, mode, maximum, minimum, basically all the descriptive statistics variables in this table. However, they weren't all useful for actually making box charts, which I'll show you next on the slide. So I ended up choosing the top three variables that were unique indicators for our research questions to actually make the box charts of. And I also decided to choose that the unit would be per capita because it'd be easier to compare all the variables together and within each variable. As you can see here, this is the GDP per capita box plot. There's a clear gap between the upper quartile and inner quartile range, along with a number of outliers that have very high GDP per capita. The gap between the inner quartile range and the lower quartile range is much smaller, indicating that this graph is actually more skewed towards countries with higher GDP per capita. And this makes sense since, as we explained already, we had gaps in our data, including only one LIC or low income country. Next slide. Okay. So this next slide is mostly for the research questions related to MSW. This is MSW per capita per day. If you can see, there is a large gap, about a whole 1 ton MSW production difference between the upper quartile whisker and the inner quartile whisker. There's only one outlier in this graph as compared to GDP, but mostly, most of the countries' MSW is clustered about 1 ton, since that's measured as the median, shown in the center of the inner quartile range. The upper whisker is twice as long as the lower whisker, pointing out that the waste generation is going to have a difference between different countries. Although we can't show on the descriptive statistics the actual country names or the income levels, it is important to note that there are more gaps here than maybe you would have expected. And then for our last one, this is for the last question on CO2 emissions per capita. CO2 emissions per capita is the variable that had the most similarity and the least amount of spread among countries, with only one outlier. I don't know exactly which country it is, but had very, very high CO2 emissions per capita. That means most populations have similar CO2 emissions, but I would also like to note here that because most of the countries we have are upper middle income or high income, what this graph has produced for descriptive statistics is not necessarily going to be representative of what had been in the entire data set, so it is biased.
All right, so we have some visualizations. Our first research question is, what is the relationship between total GDP per capita population, and total MSW production across countries with different income levels, which are low, lower middle, upper middle, and high income? This first graph is showing total MSW compared to GDP, which we can see that there is a strong correlation with an R squared of 0.873421. This next chart is showing total MSW compared to population, which is showing an even stronger correlation with an R squared of 0.969493. And this chart is comparing MSW and GDP per capita, which looks like there is no correlation between these two variables.
And then for our second research question, here is a visualization that shows a stacked bar chart that displays how municipal solid waste composition differs across countries with different income levels, low middle, upper middle, and high income. So this stacked bar chart shows how the composition of waste changes depending on a country's income level. And as you can see, as income rises, the share of organic waste decreases significantly while the other waste compositions increase. This can highlight that lower income countries deal mostly with biodegradable waste, while higher income countries generate more plastic and packaging waste that require more advanced recycling and waste management systems.
Research question 3. Is there a relationship between annual CO2 emissions and total municipal solid waste production across countries with different income levels, low, medium, high income, and upper medium income? With this question, we want to look at the relationship. This question is important because both CO2 emissions and waste production are connected to consumption, industrial activities, population size, and economic development. The scatter plot compares annual CO2 emissions on the x-axis with total municipal solid waste generated on the y-axis. Each point represents a country, and the colors represent income level. The trend line shows a strong positive relationship with an R squared value at around 0.87. What this means is that the countries with higher annual CO2 emissions generally also produce more total municipal solid waste. This makes sense because both variables are often connected to larger economics, higher production, more consumption, and larger populations. One thing to notice is that the high income and upper middle income countries tend to cluster more along the trend line, while lower income and lower middle income countries are more spread out. This suggests that income levels affect how waste and emissions relate to each other, but the overall pattern is strongly positive. This map gives us a different way to look at the relationship by focusing on per capita values. The size of each circle represents municipal solid waste per capita, and the color shows CO2 per capita. So instead of only looking at total waste and total emissions, this helps us see how much waste and CO2 are associated with the average person in each country. This is useful because total values can be heavily influenced by population size. A large country may produce a huge amount of waste, but that does not always mean each person is producing more waste. Looking per capita helps show differences in lifestyle, consumption patterns, and development.
Great. So now I'll go into the conclusions from our research questions. So for the results, I presented this as research question 1, research question 2, and research question 3. Ming, do you want to give a bit more context on research question 1, the results you found?
Yeah, so there was a strong positive correlation between MSW and total GDP, and also MSW and total population, which makes sense since with more people, they would generate more waste. However, GDP per capita was not correlated to MSW generated at all, which was interesting.
For research question 2, as Grace mentioned, the more wealthy, so the higher income countries, had less amounts of organic waste produced in comparison to all the other materials such as plastic and paper, which is less compostable and harder to degrade over time, or it takes longer to degrade over time. If not, it can't, or it also can't be degraded at all. For research question 3, the higher income and upper income countries clustered together towards the center and had a strong positive correlation with the line. In particular, higher income countries had higher annual CO2 emissions compared to our other variable, which was MSW, while lower and lower middle income countries had relatively more municipal solid waste generation in proportion to their annual total CO2 emissions. Some of the limitations in future research presented include data, transparency, and time being our limitations. So for data, we've talked about it repeatedly now, but we only had one lower income country that fit all the criteria we had when we were cleaning our data. And so we couldn't actually see the full profile of what the results would be for the research questions when it came to low income countries and actually even low middle income countries, since we only had a handful in comparison to upper middle income and high income. Also, with data, there was the issue of transparency. There was like because our data and our results were skewed, this points to there being a difference in like how waste is accounted for and misrepresent or possibly misrepresented or misinterpreted at the original point of data collection, not even data organization or, making public data more accessible. There are so many gaps in like the data that it kind of speaks to maybe a lack of transparency within the waste reduction and waste recycling processes, because if there actually was more data, it would make us feel more certain within our research questions and our results that our interpretations are actually applicable and reasonable for what is out there. But because there isn't actually that data, we can't make a good judgment on if it's transparent enough of a process. And the last one was time. Because we only represented 1 year, the year of 2022, this is not a longitudinal study by any means. The data did have a long range of time as what a waste has been an ongoing project for years, but because there was only um, a couple of years that had pretty like robust or more complete data available, we could only choose it for 1 year. So this is only a very limited snapshot of how waste looks like across the world. For further research, in order to judge the validity and success of possible waste management solutions, I think that these questions need to be taken into consideration. So for social justice, how are people being impacted? Not just like who are the people being impacted, such as economics and demographics, but how are people impacted? We know from our background research that waste does not follow like circular cycle and actually is like um sometimes like quite non-linear. Like waste from one country actually gets transported to another because that country either needs money or has become responsible for the actual like environmental health and environmental sustainability burden of dealing with waste. And for like making actual solutions in the future, we have to consider how realistic it is for more sustainable solutions within different countries, considering their income level, because waste solutions can also become a burden that become unsustainable over time if it doesn't work for a country or isn't a good fit. And then for the final one, I think this is quite positive, but we could also focus on collaboration more. What is being done in one country that can be adapted for another country, and maybe that will help increase the success across waste management. So that's it for our presentation. Thank you for watching.
Thank you, Will Patron.